Example 1. We want to solve the following system. Y equals x squared plus 1 and y equals 4x plus 1. So we can see in this system, the first equation is the equation of the parabola. It's quadratic, so its graph would be parabolic. The second equation is linear, so we know it's going to be a line. So this will be easy for us to verify graphically after we solve this algebraically. So it's nicely set up for substitution. We can see that because we've got both equations solved for y. So we can easily substitute one equation into the other for y. So I'm going to substitute the x squared plus 1 in for the y in my second equation. So if I substitute, that will give me x squared plus 1 equals 4x plus 1. So now I have a quadratic equation that I can easily solve here by hand. So if I subtract the 4x from both sides and subtract 1 from both sides to get a 0 on the right side, that'll give me x squared minus 4x equals 0. And that's easily factorable. We can factor out an x. So if we factor out an x, that'll give us x times x minus 4 equals 0. And then I can use my zero product property to set both of these factors equal to 0. And then I add the 4 to both sides here, and I get x equals 4. So I've got two apparent solutions, 0 and 4. But remember, in our system, we've got to get an ordered pair solution. So I'll substitute each of these x values back into either of the original equations because it has to work in both. And that'll give me my ordered pair solutions. So I'll substitute into the first equation. So I've got my y equals 0 squared plus 1, which would give me 1. So that gives me an ordered pair solution of 0, 1. And then if I substitute the 4 in for my x, that will give me 4 squared plus 1. 4 squared is 16 plus 1 is 17. So that gives me a second ordered pair solution, 4, 17. So remember, it's very important to check for extraneous solutions. So we have to check both of these in both original equations. So I'll check here. So I'll first check my 0, 1. So I'll put that 1 in for the y in the first equation. So 1 equals 0 squared plus 1. And then 0 squared is 0 plus 1 is 1. So that works. And then I'll check the 0, 1 in the second equation. So I'll put the 1 in for the y equals 4 times 0 for the x. Oops. So I get 1 equals 4 times 0 is 0 plus 1 is 1. So 0, 1 works. We can circle that solution. Now let's check our second apparent solution, the 4, 17. So I'll substitute my 17 in for the y into the first equation, and then I'll get 4 squared plus 1. So I have 17 equals 4 squared is 16 plus 1 is 17. That's good. That works. And then I'll put my 17 into the second equation for y equals 4 times 4 for that x plus 1. So I've got 17 equals 4 times 4 is 16 plus 1 is 17. So that works. So I can verify both of those solutions are correct. Now let's look on our graphing calculator to verify this algebraically. So here are my two equations entered into the y equals editor, the x squared plus 1 and the 4x plus 1. So we know what to expect. We know to expect a parabola and a line, and according to our algebra, they're going to intersect twice. So I'm going to graph here on a standard viewing window first, just because that's what we typically start with. But we know that one of our solutions is going to fall outside that viewing window, one of our apparent solutions. So we've got that 4, 17. Ooh. There we go. We've got that 417, which is going to fall outside that standard viewing window. So let's adjust our window here. And let's go up to a y max of 20 so we can include that 17. So here's our parabola, our x squared plus 1, and there's our 4x plus 1. Now we can see 2 points of intersection, and one certainly does look like 0, 1, and the second one certainly looks like 4, 17. And we can verify these by calculating the points of intersection, so we can hit second trace to calculate. Intersection, option 5. So it's asking, is this the first curve, x squared plus 1? Yes, hit enter. Is this the second curve, 4x plus 1? Yes, hit enter. And then we have our cursor close to this first one. Let's first look for the 0, 1, and it actually looks like it is exactly 0, 1 right here, but we've got to verify it by calculating it. So hit enter one more time, and that verifies that point of intersection 0, 1. So we verified that solution. Now let's do it again with our other point of intersection. So again, is this our first curve? Yes, x squared plus 1. Is this our second curve? 4x plus 1. Yes. Now we want to move our cursor, though, closer to our second point here. So we'll hit enter one more time. And we do verify our second solution, 417. So I'll drag this into our notes here. And you guys might want to make a little sketch in your notes just to refer back to this graphical check.